Okay, first let's go through the concept of the second derivative. So how do we read this?
D square y over dx.
Okay, yeah, that's what usually people read it as, but it's not correct. It is d2y over dx squared. Okay, so d2y over dx squared, what's the meaning? That means I'm going to differentiate the gradient. Correct? I will differentiate the gradient. So what does differentiating the gradient means? That means this is the slope, right? So what is the rate of change of the slope? How is the slope changing? Okay, this one you try to like this, set it in into your head. Again, I got slope. So dy dx is the slope. What is the meaning of slope? That is the change in the y over the change in the x, right? So you get the slope, right? So if I differentiate the slope, then I'm checking how is the slope changing. How is the slope changing? When I have a slope like this, let's look at some numbers that we randomly come up with. Okay. So what is the slope of this? Let's assume it is -3. What about this? Will it be -4 or -2? So it's a bit more gentle, right? -2.
Oh yeah, -2.
Then this one would be
-1.
-1. This one 0, 1. We just randomly pick up some numbers going from left to right. So what is happening to the slope? The slope is increasing. So the word we use is increasing. The slope is increasing, right?
Yes.
Okay. So increasing means it's more than 0. So the rate of change of the slope, or the change in the slope, the change in the slope is in an increasing manner. So d2y over dx squared will be more than 0, increasing. What type of turning point will you get for this type of diagram? When the d2y dx squared is more than 0, what type of turning point? Yeah, so you must memorize this. More than 0 is minimum point. d2y dx squared more than 0 is minimum point. So your job for today is to memorize this. You just need to memorize one only. You can memorize one of them, the other one, quite obvious, right? So make a guess. d2y over dx squared, how do I know it's maximum? Less than 0, that will be maximum. Okay, now if you look at the slope again in red color, so I have a number here that's getting less and less steep, right? And it's a positive slope. So I got, let's say 3, 2, 1, and finally I reach 0. Then I get -1, -2, and then now steeper and steeper, -3. So the change in the slope is decreasing. Okay, so the change in the slope is less than 0. So first I need to find the stationary point. Let's do it very quickly. So I need to find dy dx, which is 3x squared minus 12x plus 9. Bring down the power minus 1. Bring down power minus 1. Bring down power minus 1. And then differentiate the constant is 0 because the power is 0. Okay, now when it's equals to 0, let's factorize it. I will have x squared minus divided by 3, divided by 3, and our x minus 1, x minus 3 equals to 0, x equals to 1, x equals to 3, and the y value will be 6, and y equals to 2. Nothing new, exactly the same as 2 days ago, exactly 100%, same question some more. Now how do I find whether is it a maximum point, minimum point? So I need to use the rate of change of the slope. So I need to use d2y dx squared. So first, I differentiate this one more time, 6x minus 12. And I sub in the x value. For the first one, this is the point I'm looking at. So I need to sub in x equals to 1. When x equals to 1, d2y over dx squared equals to 6 minus 12. Is this a maximum or minimum point? Yeah, it's less than 0. You think opposite, right? I believe your head will have already been telling you, I do think of the opposite. Less than 0 is maximum. And don't go and stress yourself why less than 0 maximum. It was discussed at the beginning why less than 0 is maximum. Just memorize. From now, just memorize. So if I try x equals to 3, d2y over dx squared, 18 minus 12 is 6, greater than 0. And this is the minimum. How do I conclude? And please don't end here. And really, please don't end here. I may not give you the final mark. I have a high tendency I don't want to give. Because you have to write this down, that this is a maximum. You see, if I don't write this down, the examiner really got to hunt for it. I know there's a 3 you sub in. I know it's a minimum, but what is the point? What is the coordinate? So it is actually 3, 2, and that's the minimum. You have to write this. If you really want to do well for AMAX, please write this down. Okay, one last thing I have to say before I conclude this video is, what happens when d2y over dx squared equals to 0? When d2y over dx squared, sometimes when you sub in the number, right? Okay, when you sub in a number, and it happens to be equals to 0, not negative, not positive, but exactly 0, we call this that the nature of the stationary point. But I don't have to write the full statement. Because once you get this, you sway already. Nobody cares about what you write already. Nature of the stationary point is, okay, don't have to copy this, but it's undeterminable. Okay, let's use the word used in the resource book. The word that they use is, there's no definite conclusion. So there's no definite conclusion. Why? Okay, the reason is this. When d2y over dx squared equals to 0, it can be a maximum point, it can be a minimum point, or it can be points of inflection. We don't know. So how do we determine that? Whether is it maximum, minimum, or points of inflection? We do the 3 by 4 thing again. So 1, 2, 3, 1, 2, 3, 4. Okay, so we have to do this, this, and this to look at whether is it a maximum, minimum, or points of inflection. Okay, all right, that's all. Jacob, can I have you to stop?
So when we
Yes.